In northern Chile, there is a landscape so intensely dry and hostile, astrobiologists use it as a direct testing ground for the surface of Mars. Some weather stations here have gone years without recording a single drop of rain. This diagram shows exactly why. The Atacama is boxed in by massive geographic barriers. To the east, the towering Andes Mountains act as a physical wall. Weather systems rolling in from the Amazon are forced upward, depositing all their moisture on the eastern slopes and leaving only completely dry air to cross over into the desert. And to the west, it faces the Pacific Ocean, but it gets no help there either. The icy Humboldt Current flows up the coast, cooling the air immediately above the ocean so much that it prevents water from evaporating and forming rain clouds. Concluding, definitive. Between a mountain range blocking the east and a freezing ocean current suppressing the west, the Atacama sits inside a natural waterproof fortress. By all rules of atmospheric physics, measurable rainfall here should be practically impossible. But occasionally, the sky opens. Instead of a sprinkle, bone-dry ravines are suddenly overwhelmed by a violent flash flood of thick, rushing water. The rainfall volume is so immense, it pools into vast temporary inland lakes. In a matter of days, wading flamingos occupy what is normally an endless expanse of dust and rock. When rain hits a normal environment, the soil absorbs it. But in a hyper-arid desert, decades of intense sun bake the earth into a hardened, nearly impermeable crust. When sudden moisture arrives, the ground physically cannot absorb it fast enough, forcing the water to surge over the surface as highly destructive runoff. We have a geographic region perfectly engineered by nature to repel water, locked behind impenetrable atmospheric defenses. So how does it suddenly succumb to catastrophic flooding? The answer lies in an atmospheric trigger capable of overpowering those natural defenses, the El Niño climate pattern. This thermal map shows the precise mechanism. During an El Niño event, ocean temperatures across the central and eastern Pacific heat up dramatically, shown by this massive band of heat. This warming alters global wind currents, bulldozing heavy moisture past the cold air blockade. When that moisture reaches the desert, the human cost is severe. Local towns and infrastructure are built for an environment that never sees rain. The sudden influx of millions of gallons of water rips through these unprepared settlements, caving in roads and burying entire neighborhoods in deep mudslides. El Niño acts as a temporary atmospheric override switch. It forces a geography designed for extreme drought to immediately process extreme flooding, turning a protective environment into a deadly trap. But once the floodwaters recede and the mud begins to dry, a secondary transformation takes place. The Atacama is full of extremophile seeds and microbes. To survive the brutal dryness, they enter a state of deep biological stasis. They can wait patiently in the soil for decades, doing absolutely nothing, until that flood provides the moisture trigger they need to rapidly shoot upward. The result is the Desierto Florido, the flowering desert. Within days, endless miles of gray wasteland erupt into a dense ecosystem of wildflowers and pollinators. The desert, it turns out, is rarely dead. It is an ecosystem resting in a permanent pause state, simply waiting for the right atmospheric anomaly to push play. This biological explosion in Chile gives us a unique window into a much larger global issue. This animation illustrates a core physical reality of climate change. As the global average temperature rises, the atmosphere acts like a larger sponge. Warmer air expands, making it capable of holding significantly higher volumes of water vapor before it finally lets it go. Rather than creating a universally wetter planet, this larger atmospheric sponge triggers deep volatility, long, agonizingly dry periods violently interrupted by massive, sudden spikes in rainfall. This makes the Atacama a real-time laboratory, showing us exactly how extreme weather events bypass long-standing environmental norms. If the absolute driest place on Earth can be overwhelmed by sudden catastrophic floods and transform into a blooming ecosystem overnight, it proves a stark point. No environment on this planet is perfectly static, and the climate rules we thought were permanent are already beginning to rewrite themselves.